Hi everyone, this is Teacher Ethel, and today I will be discussing the normal curve, normal distribution, and standard normal distribution, their definition and characteristics. A normal curve is a symmetric, graphical, or visual representation of a normal distribution. It is a bell-shaped curve with the mean, median, and mode having the same values. A normal distribution, on the other hand, is the most widely known and used of all distributions. It can be used for various world applications. For example, individuals' height and weight, and even IQ, follow closely a normal distribution. It is also called a Gaussian distribution because it was named after a German mathematician named Carl Gauss, who first described it. It is a mathematical model based on the law of chance or probable occurrence of certain events. Normal distribution is a symmetrical probability distribution where data clusters around the mean with the highest frequency in the center and decreases gradually towards the tails in both sides. The right side of the center is the mirror image of the left side. The percentage of distribution of scores or values by locations below or above the mean are equal, and the curve has no boundaries in any direction. In a normal distribution, almost all, or approximately 99.7% of data points or values fall between 3 standard deviation units below and above the mean. We can see that in a normal distribution, approximately 2/3 or 68% of the data points or values lie within 1 standard deviation of the mean, with 34.13% of data points or values lying between the mean and 1 standard deviation above the mean, and an equal proportion of data points or values lie between the mean and 1 standard deviation below the mean. However, each normal distribution may come with its own mean, standard deviation, and units, which may present some problems or issues. And in order to solve this issue, we standardize the normal distribution. Hence, we have the standard normal distribution. A standard normal distribution is a normal distribution of standardized values called z-scores. In other words, the scores or data points from this distribution are called z-scores, hence the name z-distribution. The z-score tells us how many standard deviations the score or values or data points is above or below the mean. When we say above the mean, we look at the values to the right side of the mean, while the values below the mean are on the left side of the mean. A standard normal distribution has a mean of 0 as shown by the mu sign, and has a standard deviation of 1 as shown by the sigma sign. The difference between a normal distribution and a standard normal distribution is that a normal distribution can take on any value as its mean and standard deviation. On the other hand, a standard normal distribution has always a fixed mean and standard deviation. The standard deviation either stretches or squeezes the curve. A narrow curve represents a small standard deviation, while a wider curve represents a large standard deviation. Let's consider the following example. Let's say the height of the grade 6 students in your science class is normally distributed with a mean of 63 inches and a standard deviation of 4 inches. Your unstandardized distribution would look like this. A mean of 63 inches spreading out with increments of 4 inches. We have the mean of 63 inches added with standard deviation of 4 inches, and that would be 67. 67 is the data point or value, one standard deviation above the mean. 67 plus 4 is equal to 71, which is 2 standard deviations above the mean. On the other hand, the mean 63 inches minus the standard deviation of 4 inches is equal to 59, which is 1 standard deviation below the mean, which is this one. And 59 minus 4 is equal to 55, which is this one, which is 2 standard deviations below the mean. If a student happens to have a height of 65 inches, the height will fall here in this black line, 65, slightly above the mean. If we are to standardize the data point or height value, we have to transform the value to z-score. To solve for z-score, we have the formula. Z-score is equal to the value or data point x minus the mean. Okay? It can be represented with a mu sign, or m, divided by the standard deviation. Values that are larger than the mean have positive z-scores, and values that are smaller than the mean, the value has a z-score of negative. If the value is equal to the mean, the value is or has the z-score of 0. So to solve for the z-score of the given example, with the height of the students of 65 inches, we minus the mean from this 65. So 65 minus 63 is equal to 2 divided by the standard deviation of 4. Then the result is 0.5. Comparing the two distributions, we can see that the values have the same location. The value or data point is half of the standard deviation above the mean. So here are the key points that we have to remember. Normal curve is a symmetric graphical or visual representation of a normal distribution. Normal distribution, on the other hand, is a symmetric unimodal distribution with the mean, median, and mode having the same value. Most scores are near the mean, median, and mode, with fewer scores as it moves farther from the center. To take advantage of the concepts of normal curve, we need to convert or transform raw scores or values to standard scores, like z-scores. Standard normal distribution has a mean of 0 and has a standard deviation of 1. And that ends our discussion on normal curve, normal distribution, and standard normal distribution. And here are the references used in this video. Thank you for watching. Hope this video helps. Stay safe and healthy always, and see you in my next videos.